Define and graph exponential function. Here we have f of x equal to a to the power of x. For a is greater than 0 and a is not equal to 1, and all real number x. So this defines the exponential function with the base a. So this a is the base. We want to find a graph of f of x equal to 10 to the power of x. So here our base is equal to 10. We can use the chart here, this little table, and substitute some values for x. Okay, the first column would be the values of x. Second column here would be the value of f of x, which is 10 to the power of x. If x equal to 0, 10 to the power of 0, 10 to the power of 0 would be equal to 1, right? Anything to the power of 0 is equal to 1. So here we have our graph passing through point 0 and 1, which is right there. Okay, it's right there. If I increase the value of x, if I have x equal to 1, you notice that y or f of x would be equal to 10. And as I increase the value of x just a little bit, 2, this graph exponentially increases here. So you see there's a sharp increase here as I increase the value of x with just a little bit. So you can see, kind of predict the graph goes this way. And as I decrease the value of x, if I let x equal to -1, so then you would get a number. Let's take a look here. If I let x equal to -1, so then you would have 10 to the power of -1, which is equal to 1 over 10. You get the number that are less than 1. Let's see, if I x equal to -2, that would be 10 to the power of -2, which is equal to 1 over 10 to the power of -2, or 1 over 100. See, the number gets closer and closer to 0. It gets very small. You can imagine if I let x equal to 100, that would be 1 over, that would be 10 to the power of -100. The numbers become really, really small. It gets closer and closer to 0 from this end. So this would be a shape of the graph, just by looking at these data. Graphing an exponential function when a is between 0 and 1. Looks like a misprint there at the top. A between 0 and 1. Let's fix it. Okay, here when the number is like 1/4. So if you look at the chart once again, if x equal to 0, y still, or g of x still, would be equal to 1. Our graph is still going to pass us through the same point here. But this time, as I increase the value of x, then the value of g of x decreases, gets closer and closer to 0. And if I decrease the value of x, like -1, -2, and you see the value of g of x increases. So it's going to shift this way. So if you take a look at the graph side by side, so if the a is greater than 1, look at the shape of the graph. From the left to right, it increases. And if the a is less than 1, the graph behaves this way. So let's take a look at the example. Graph f of x equal to 10 to the power of x. Graph g of x equal to 1/4 x. We looked at these two examples. Let's look at the characteristic of these graphs. The graph contains the point 0, 1, which is y-intercept for both of them. You see that? For both of them, the graph going to pass us through this point 0, 1. The y-intercept passes through this point on y-intercept. the function is 1 to 1. When a is greater than 1, the graph will rise from left to right, like in this case. This is from left to right, the graph is rising. If the a is between 0 and 1, you see how it does? The graph will fall from left to right. In both cases, the graph goes from the second quadrant to the first, from left to. The graph will approaches the x-axis, but never touch the x-axis, or touches x-axis in point of infinity, never touches it. And this such line called asymptote. So the line that the graph gets closer and closer to it but never touches it is called asymptote. The domain is from negative infinity to positive infinity. The range would be from 0 all the way to positive infinity. These are the characteristics of that. So let's take a look at the example. Graph g of x equal to 2 to the power of 4x minus 3. Here we're going to make a chart. We're going to let x equal to some values. Find what 4x minus 3 would be first, and then use that to find the g of x. So if x is equal to 0, 4x minus 3 would be equal to 4 times 0 minus 3 is equal to negative 3. So y would be equal to 2 to the power of minus 3, or 1 over 2 to the power of plus 3, which is equal to 1/8. Okay, remember the a to the power of minus n would be equal to 1 over a to the power of plus n. That's how you can make it positive. So g of x would be equal to 2 to the power of minus 3. That's the same as 1 over 2 to the power of plus 3 is equal to 1 over 8. That's what it is. If x equal to 3/4, if I put 3/4 here, I'll use purposely 3/4 here so I can reduce the 4. So it would be 3 minus 3 would be 0. So anything to the power of 0 would be equal to 1. Okay, so that's another point. If x equal to 1, 4x minus 3 would be equal to 1. Then that would be equal to g of x, then would be equal to 2. 2 to the power of 1 is equal to 2. And finally, another point, if x equal to negative 1, 4x minus 3 would be equal to negative 7. Then we can find a value for g of x, which is equal to 1 over 128. So we can locate these numbers. You can see the shape of this is very similar to the one we saw earlier.